Welcome back. Here is another video where I want to tell you a little bit about what we teach in the maths department at Durham, the degree programs and the modules within the degree programs. Okay, so there are essentially, there are 4 entry degrees. These are the different degrees that you can apply for on UCAS. And these are as follows. There's a 4-year M-Math course and a 3-year BSc course. And in the past, these have roughly been 50-50, which students apply for which one of these two. And for the first time this year, there's a new course called Maths and Statistics. And they occur as both a BSc 3-year and an M-Math 4-year course as well. So you can apply for any one of these 4 degree programs. Now, the first 2 years, certainly of these 2 programs, are identical. These ones, there will obviously be more statistics content in them. But as long as you've done the relevant modules, then you should be able to transfer from one of these programs to another at any point up to the end of year 2. So certainly between these 2, it's not so important which one you apply for at this stage or have already applied for. So don't worry if you're on the BSc currently and you fancy changing to the M-Math or vice versa. That's fairly straightforward to do at the end of year 2. Now, as well as these entry degrees, there are various other degrees that you can transfer onto during your time in Durham. And most of these involve various years out, for example, year abroad degrees or industrial placement degrees. So they are what they sound like, and they occur in various different forms. So you can do a BSc with a year abroad, which is like the BSc, like the 3-year BSc, but within a year abroad. The 3rd year is spent abroad. So it lasts a total of 4 years. You do first 2 years, you do a year abroad, which doesn't count towards your degree, and then you come back and do the 3rd year. There are also M-Math versions of this, so with the same idea, basically. You do the first 2 years in Durham, do a year out, and then come back and do years 3 and 4 in Durham. And it lasts a total of 5 years. Then you have an M-Math at the end of it. And there are placement degrees in both varieties as well, 4 and 5 year placement degrees, where instead of taking a year abroad, you go for a year on an industrial placement. And there's various, basically it's up to you to apply for your placement, but you get a lot of help from the department. And in the past, basically the students that persevere with the applications do get a place. And we're building up now a portfolio of different places that people go to. That can go to. Now, there's a slightly unusual and special one, which is an M-Math G101, which is actually just a 4-year degree, but you end up with an M-Math. And the difference there is that so you do 2 years in Durham, you do a 3rd year abroad, but that 3rd year is very carefully chosen to coincide with the 3rd year in Durham, and it does count towards your final degree. And then you come back and do the 4th year in Durham. So because obviously the courses have to be very closely aligned with the one in the foreign country, there's only 2 or 3 universities that we can do this with currently. Okay, I've just been talking about maths degrees. Of course, you can also do natural sciences, and there's a separate video if you're interested in natural sciences. As to how that fits in with the maths program. So you can do maths modules within the natural sciences program, either as a joint honours or as a separate just natural sciences program. So the best bet to understand how that works is to look at the separate video that I've done on that. Okay, now how do you get onto these programs that you don't apply to at the start? Well, typically you transfer at the end of year 1. So you decide at the end of year 1 you want to do a year abroad, and then you transfer onto it. Now, of course, if you're studying abroad and the course is in a foreign language, you will need a language to do that, and that usually involves doing a module in that language in your first year. So you need to think ahead a bit about that. In order to do a module in a foreign language, you normally would need a B in A level in that language as well. So just bear that in mind. And as I've already said, all these degrees involve spending the third year away from Durham. Okay, now all the degrees in Durham University really, all the undergraduate programs, involve 6 modules a year. 6 full modules, although there are also half modules as well. So you do 6 modules per year. In the first year, it's basically a pass or fail. A pass is 40% in the exam, and you do get the opportunity to resit at the end of the summer if you fail in the first year. So all you have to do in the first year really is to pass to get through to the second year, but your marks don't count to your final degree. From the second year onwards, then there are exams at the end of each year, and they will count towards your final degree classification. So, and they count in the following ratio. So if you're doing the 3-year course, they count in the ratio 2 to 3. So your second year marks count 2/5 of the total, and your third year marks 3/5 of the total. So there's a sort of a weighting towards the final year. And similarly, in the 4-year course, they're weighted 2, 3, 4. This is how our undergraduates do. As you can see, 52% of undergrads get a first, and 83% get a first or a 2-1. This is very high, but to be honest, it reflects the quality of the students that are in Durham, of course. And our external examiners are very happy with these results. So it seems high from our point of view. From your point of view, of course, it's very good. It means if you come here, you've got a very good chance of getting a good degree. Okay, so let's talk a little bit about the subjects that we teach throughout the 3 or 4 years in Durham. Now, as you know, maths is a subject which builds on what went before. You can't start learning calculus if you don't understand addition, to give a stupid example. But that obviously continues on as you progress further up. So the first year is pretty prescribed. We have 5, if you're a straight math student, there are 5 core modules that you have to do. And these are calculus, so integration, differentiation, analysis, which is a sort of a more hardcore version of calculus, if you like, linear algebra, which is matrices and vectors, but done in a more abstract setting, and then programming and dynamics. Programming is done via coursework, unlike most of the courses which are done via exam, and we teach Python, which is a very useful program for working with mathematics, and dynamics is sort of Newton's laws, basically. And then there's a module on probability and statistics. So these are the 5 modules that you do. Now, I told you had to do 6 modules, so then there's 1 additional module you need to do, and in principle you can do any module anywhere in the university, obviously subject to, first of all, timetabling with the core modules, and second of all, subject to any prerequisites that the other department might have. But apart from that, you can do any module anywhere, and we do offer a maths module for you to do if you want to do more maths, which, to be honest, most of our students do, in fact, and that's discrete maths, which is things like graph theory and permutations and combinatorics, things like that. Okay, in the second year, this is where you start to specialize a little bit, but it's still a little bit prescribed. So there are 2 core modules, and these are both continuations of calculus, really. Calculus in many variables, analysis in many variables, or complex analysis, which is calculus of complex variables. So these are core. You need to do these, and then after that there are four. You have to do 4 modules from the following choices: algebra, mathematical physics, numerical analysis, statistical inference. And these are kind of starting actually to group together into the research groups that I mentioned in the previous video, the pure, applied, and statistics. So if you want to do pure subjects later on, you really need to do algebra. If you want to do more applied, or at least the mathematical physics types modules later on, then you need to have done that, and so on and so forth. These are full modules, and then there's a bunch of half modules, so you need to do kind of 2 of these. So again, you're starting to specialize a bit. If you're into pure number theory, then you're going to do that one. If you're into mathematical physics, then you're going to do special relativity and electromagnetism, and so on and so forth. Okay, and then in the 3rd and 4th years, then you're really starting to kind of basically do what you're interested in. And as I said, the course is split along research interest lines of the group here, so the pure and applied and statistics. And here are some example 3rd and 4th year courses. More analysis, algebraic topology, differential geometry. You can read the list here. The main point for you now, since many of them won't mean much to you, is that there's a very broad range and lots of choice on offer here. This is an interesting one, maths teaching. That gives you experience of teaching mathematics in secondary schools or even primary schools, and involves going into schools and usually doing things like, for example, writing an exam question is a common task that is set for you. I've been teaching advanced quantum theory, where we teach pretty high level quantum theory, so quantum field theory, path integral, string theory, and so on. Okay, now, as well as these things, so all of these modules, I said there are 6 modules you do, nearly all of them are taught via a final year, an exam at the end of the year. In your final year, whether that be the 3rd year or the 4th year, you will have to do a double module project. So every final year student does that. These are very highly commended by the external examiners, and they give you a sort of a flavour of doing research. So you work with a member of staff, usually with 4 or 5 other students, and the member of staff will sort of set up the project for you, give some initial reading material, and you will meet weekly to discuss with him or her. But it's very different from an examine module. It's very much up to you to kind of to lead your own work and follow your own kind of interests. And a lot of students really get into that and find it a really nice experience. So again, there's a vast choice, and it's again informed by the research interests of the staff. So here's some example 3rd year projects. Again, vast number of different things. Geometry of the universe, so this is working with general relativity, which you won't learn in a 3rd year course. There is a 4th year module on general relativity. Fermat's last theorem, most people have probably heard of, so you can learn about that properly to some extent. Knot theory, calculus of variations, and so on and so forth. And then the 4th years tend to be even more specialised, because obviously you've got a year more mathematics under your belt, so you can go a bit further, and it really gets quite close to the research that people are doing. And indeed, sometimes students end up writing papers with their supervisors based on their project. Okay, good. That's all I want to say in this video. There'll be another video where I discuss how we teach: lectures, tutorials, problems, classes, so on and so forth. I hope to see you soon in that. Thank you.